Dear students, welcome to this lecture on motion in straight line, which is given as chapter number 3 of physics for class 11. Motion is common to everything in this universe. We walk, run, and ride a bicycle. Even when we are sleeping, air moves in and out of our lungs and blood flows in arteries and veins. We see leaves falling from trees and water flowing down a dam. Automobiles and planes carry people from one place to other. The earth rotates once every 24 hours and revolves around the sun once in a year. The sun itself is in motion in the Milky Way, which is again moving within its local group of galaxies. Motion is change in position of an object with time. How does the position change with time? In this chapter, we shall learn how to describe motion. For this, we develop concepts of velocity and acceleration. Introduction. Motion of object along a straight line is known as rectilinear motion. Motion is the change in position of an object with time. If a body does not change its position as time passes with respect to frame of reference, it is said to be at rest. And if the body changes its position as time passes with respect to frame of reference, it is said to be motion. So, if a body does not change its position with time with reference to time, it is at rest, and if the body changes its position, then it is moving or in motion. Frame of reference. It is a system to which a set of coordinates are attached with reference to which observer describes any event. This coordinate system, along with a clock, constitutes a frame of reference. It is convenient to choose a rectangular coordinate system consisting of three mutually perpendicular axes labeled x-axis, y-axis, and z-axis. The point of intersection of these three axes is called origin O and serves as the reference point. The coordinates x, y, z of an object describe the position of object with respect to its coordinate system. To measure time, we position a clock in this system. Rest and motions are relative terms. It depends on the frame of references. Position, path length, and displacement. Now we will learn about the position, path length, and displacement. If one or more coordinates of an object change with time, we say that the object is in motion. Otherwise, the object is said to be at rest. That means if the coordinates do not change, then the body is said to be at rest with respect to this frame of reference. Path length. Distance is actual path length covered by a moving object in a given interval of time. Say for example, please see the figure on the right hand side. If a body is in point A and it goes to point B, then we say the body has moved from point A to point B. While reaching B, it can take another point. It can go from A to C and C to B, and it comes back to B. So the position has changed from A to B, and it can be A to C and C to B. Therefore, path length is a scalar quantity. Path length is actual motion from A to C and C to B. That is, it's a scalar quantity and its path length is AC plus BC. So AC plus BC is the path length. Dimensions of path length are m to the power of 0, L to the power of 1 and T to the power of 0 within square brackets. Unit of path length is meter in SI. Displacement. A displacement is the change in position vector, that is a vector joining initial to final position. That means in this diagram, if A has moved to B, then displacement is change of position. Position vector, a vector joining initial position is A and final position is B. So AB is the displacement. Displacement is a vector quantity. Example in the figure AB, vector AB. It is written as AB with an arrow on the head. Dimension. Its dimension, displacement dimension is m to the power of 0, L to the power of 1, T to the power of 0 within square brackets. Then unit of displacement is meter in SI unit. Net displacement. If S1, S2, etc. up to Sn are displacements of a body, then the total net displacement is vector sum of individuals. S is equal to S1, vector S1 plus vector S2 plus etc. up to vector Sn. Comparison between distance and displacement. Distance is always greater than displacement. Please see the figure on the right hand side. A to B is the displacement and distance can be A to C plus C to B. Hence, here AC plus CB is greater than AB. For a moving particle, distance can never be negative or 0, while distance can be greater than 0, say greater than 0 if you take A as the origin and move towards B, so displacement is greater than 0. But displacement can be greater than 0, or if it remains and goes to B and come back to A, displacement will be 0. Or it can be less than 0 if it goes to in the negative direction. For motion between 2 points, displacement is single valued, while distance depends on actual path and so can have many values. In the figure shown is A to C and C to B. It can take another point, C to D, D to E, and then again come back to that. So, motion between two points, displacement is single valued. A to B is single valued, while distance depends on actual path, so can have many values. For a moving particle, distance can never decrease with time, while displacement can. Decrease in displacement with time means body is moving towards the initial position. So decrease in displacement means body is coming back to A, initial position. In general, magnitude of displacement is not equal to distance. However, it can be so if the motion is along a straight line without change in direction. So, displacement can be equal to distance if it is a straight line motion without change in the direction. So, types of motion. Please see the diagram above on the right hand side. This diagram wherein this is the origin. O can be an origin, x-axis, perpendicular to x-axis is y-axis, and z-axis is perpendicular to both y-axis and x-axis. So this is there can be three types of motion. One dimensional motion if it moves only along the x-axis, and two dimension if it is a plane that is comprising of x-axis and y-axis, and three dimensional if it is a space located between anywhere between x, y and z axis. So let us compare. One dimensional motion is a motion of body is in straight line. And in two dimensional motion of body is a plane. So it is a plane of x and y axis. And in three dimensional it will be motion of the body is in space. So where you will have components in x, y and z. Point is in space. So it has component in all the three axes. Then in one dimensional only one coordinate changes with time. Okay, if one dimension will be time axis and y will be displacement or distance will be in one axis. Two coordinates change with time. In two-dimensional motion, both x-axis and x component and y component change. In three-dimensional, three coordinates change with time. So all the three possibilities are that x can change, y can be changed, and z can change. So that is three-dimensional motion. Example: motion of a car in a straight line. Free falling body. An example of a two-dimensional motion is motion of a car in a circular turn, motion of a billiard ball. These are the two examples. And in three dimension, example is a motion of a flying kite, where a flying kite. Kite can move in vertically up, horizontally up, down, and this direction, near and far like that. So it has three dimensions. Average velocity and instantaneous velocity. Definition. Average velocity is defined as the change in position or displacement delta x divided by the time interval delta t in which displacement occurs. Please see the figure on the right hand side. The position of the object or a particle P is shown here. Position. This is position versus time graph. Here the particle is at rest. So with respect to time, it does not change. The position remains same, that is at this point. In the figure B, the position is changing. It is increasing with respect to t. X is in the t is the x-axis is time and the y-axis is the position. So position is, as the time increases, position is also increasing. So the position is positive here. Whereas in the diagram C, the position is decreasing as we increase the time on the x-axis. The position is decreasing. Hence, the position is negative. So the average velocity represented by V bar, this is V bar is equal to x2 minus x1 over t2 minus t1, where x1 and x2 are positions of the object at time t1 and t2 respectively. Therefore, V bar average velocity is equal to x2 minus x1 divided by t2 minus t1, that is equal to the difference between x2 and x1, that is x2 minus x1 is equal to delta x and t2 minus t1 is equal to delta t. So average velocity is a vector quantity having a symbol V arrow over the head of the, it is the symbol is V over on the arrow on the head. Its dimensions are m to the power of 0, L to the power of 1, T to the power of minus 1 within square brackets. Its unit is meters per second. So velocity is meter per second in SI unit, centimeters per second in CGS system. The average velocity can be positive or negative depending on the sign of displacement. It is 0 if the displacement is 0. So here the displacement is 0. The average velocity is 0 in case A, positive in case of B, this is the figure B, and negative in case of figure C. B. Uniform velocity. A particle is said to have uniform velocity if its magnitude as well as the direction of its velocity remains same, and this is possible only when particle moves in the same straight line without reversing its direction. Say here it is a uniform velocity, constant angle, and it is direction is same because angle theta is same and it is increasing, velocity is changing. Non-uniform velocity. If a particle is said to have non-uniform velocity if either of the magnitude or direction of the velocity changes or both change. So here it is positive. If it becomes negative, then it is a non-uniform velocity. Instantaneous velocity. Instantaneous velocity is defined as the rate of change of position vector of a particle with time at a certain instant of time. So it can be defined as instantaneous velocity, also represented by vector v, equals limit delta x by delta t as delta t tends to 0, that is equal to dx by dt. Please see the figure here, second figure on the right hand side. Here the particle is moving from P1 to P2 and its position on the curve is Q2. And then at the third point it moves to another point P and its position is Q. In that case, it is slowly becoming 0. Delta t is becoming 0. Here as we approach from P2 to P, the delta t is tending to 0. That is change of timing. Let us solve a problem connected with average velocity and speed. Question number 1. A car is moving along a straight line OP as shown in the figure. It moves from O to P in 18 seconds. That is O to P, it moves in 18 seconds and returns from P to Q in 6 seconds. So distances are given here in the x-axis. It starts O is at 0 and these are the positive directions 40, 80, 120, 160, 200, 240, 280, 320, 360. So O to P is 360. So now the question is, what are the average velocity and average speed of the car in going part A is from O to P and part B is from O to P and back to Q. That is, in the part B it has to go to O to P and it should come back to Q. These are the two parts. So let us solve it. You please follow this diagram very meticulously. Answer A. Average velocity equals displacement over time interval. Therefore, average velocity represented by V bar is equal to displacement O to P is 360. 360 and it is given that it travels in 18 seconds. Therefore, time interval is 18 seconds. 360 by 18 is equal to 20 meters per second. Average speed is given by total path length divided by time interval. So, total path, it is going straight to P. Therefore, it is 360 divided by 18. It is 20 meters per second. So, average speed and average velocity both are 20 meters per second. Part B. In part B, it goes to O to P, from O to P and back to Q. Therefore, again the definition is average velocity is equal to displacement over time interval. That is V bar is equal to, it goes, see, velocity means it goes to O to P 360 minus it comes back. It comes back from 360 to 240. That is the average distance. Displacement is only O to Q. Therefore, it is 240 divided by the time interval. It takes 18 seconds to go from O to P, and to travel from P to Q, it takes 6 seconds. So, therefore, the total time is 18 plus 6. Therefore, V bar average velocity is equal to 240 divided by 24. That is equal to 10 meters per second. Therefore, average speed is total path length. So, speed considers total path length. Path length is 360 plus 60. That is OP plus PQ divided by delta T. Therefore, it is 360 plus 120. So, this P to Q is 120. Therefore, 360 plus 120 divided by 18 plus 6. That is equal to 20 meters per second. That is the answer. Next question. The position of an object moving along x-axis is given by the equation x is equal to a plus b into t square, where a is equal to 8.5 meters and b is equal to 2.5 meters per second square, and t is measured in seconds. What is its velocity at t is equal to 0 seconds and t is equal to 2 seconds? What is the average velocity between 2 seconds and t is equal to 4 seconds? So here the relationship is given, x is equal to a plus bt square. The values of constant a and b is given, and t is measured in t seconds. Question is, at t is equal to, what is its velocity? We have to find the equation for velocity, and at different timings, that is t equal to 0 and t equals 2 seconds, and average velocity between t is equal to 2 seconds and 4 seconds. Let us solve it. We know v is equal to dx by dt. So therefore we have to differentiate. So to solve this problem, you should have some knowledge of differential calculus. So it is d by dt of a plus bt square. If we take differential of a plus bt square, we will get 2bt. Therefore, at t is equal to 0, v is equal to 2 into b. b is 2.5 given, into 0. Therefore, t is 0, we get v is equal to 0. Therefore, at t is equal to 2 seconds, we get v is equal to 2 into 2.5 into 2. That is equal to 10 meters per second. Therefore, average velocity is equal to a plus 16b, that is 4 into 4, 4, 4 t square. 4 second, 4 square is 16b. T square is at t is equal to 4, it is a plus 16b minus initially minus a plus 4b divided by 4 minus 2. That is equal to 12b. A and a gets cancelled. 12 minus 4 is 12b divided by 2. That is equal to 6b. 6 into 2.5. That is equal to 15 milliseconds. That is the answer. Average speed and instantaneous speed. Average speed is defined as the total path length. Please remember, total path length traveled divided by the total time interval during which motion has taken place. So average speed V average is equal to distance traveled divided by time taken. That is equal to del S divided by del T. That is equal to S1 plus S2 plus etc. divided by T1 plus T2 plus etc. Where S1, S2 etc. are distances covered with speeds V1, V2 etc. respectively. It is a scalar quantity having a symbol V. So here it is a scalar quantity. There is no vector sign, that is, there is no arrow over its head. Dimensions are m to the power of 0, L to the power of 1, T to the power of minus 1 within square brackets. Its unit is meters per second in SI. And uniform speed, when a particle covers equal distances in equal intervals of time, no matter how small the intervals are, then it is said to be moving with uniform speed. That is, it covers equal distances in equal time intervals. Non-uniform or a variable speed. In non-uniform speed, particles covers unequal distances in equal intervals of time. See here, the distances are unequal. It may be first 10 kilometers per second, next maybe 20, then it may be 30 kilometers per second. That is, it varies unequal distances. First 10 kilometers, then 20 kilometers, then 30, again back to 20, but the time intervals per second remains same, equal intervals. In such cases, non-uniform or variable speed. Time average speed. When particle moves with different uniform speed V1, V2, V3, etc. in different time intervals T1, T2, T3 respectively, its average speed over the total time of journey is given as V average is equal to total distance covered over total time elapsed. That is equal to D1 plus D2 plus D3 plus etc. divided by T1 plus T2 plus T3. Therefore, the distance covered is velocity speed into time. Therefore, V1 T1 plus V2 T2 plus V3 T3 plus etc. divided by T1 plus T2 plus T3. Special case, when particle moves with speed V1 up to half time of its total motion and its rest time, and in rest time it is moving with a speed V2, then V average is equal to V1 plus V2 by 2. Instantaneous speed. If the speed of the particle at particular instant then we say speed, it is usually means instantaneous speed. So hence instantaneous speed is the speed of particle at particular instant. When generally we say speed, it means instantaneous speed. The instantaneous speed is average speed for infinitesimally small time of interval, that is delta t tending to 0. Instantaneous speed v is equal to limit of delta s, that is the distance traveled divided by time taken, as time taken delta t tends to 0, that is ds by dt. Comparison between speed and velocity. First, let us compare the instantaneous speed and instantaneous velocity. So please note instantaneous speed and instantaneous velocity. Instantaneous velocity is always tangential to the path followed by the particle. That is, it is tangential. If you take a tangent at any point on the path of the particle in motion, then that is called instantaneous velocity. A particle may have constant instantaneous speed but variable instantaneous velocity. So, particle can have constant speed but variable instantaneous velocity. The magnitude of instantaneous velocity is equal to the instantaneous speed. If a particle is moving with a constant velocity, then its average velocity and instantaneous velocity are always equal. So if the velocity is constant, then speed also, average and instantaneous velocity are equal. If the displacement is given as a function of time, displacement is a function of time, then time derivative means d of s divided by dt will give the velocity, that is displacement divided by time is the velocity. Next, comparison between average speed and average velocity. Previously, we compared instantaneous speed and instantaneous velocity, that is at particular instant. Whereas here we are comparing average speed and average velocity. Average speed is a scalar while average velocity is a vector, both having the same units, meters per second, and dimensions are also L t to the power of -1 within square brackets. Average speed or velocity depends on the time interval over which it is defined. See, for a given time interval, average velocity is single valued, while average speed can have many values depending on the path followed. This was explained in our previous slide. If after motion body comes back to its initial position, then velocity or vector v equals 0, as delta r, the displacement, is 0. With this, we have concluded our discussions on position, path length, displacement, average velocity, average speed, instantaneous velocity, and instantaneous speed as given in section 3.2, 3.3 and 3.4 of motion in straight line. In the next lecture, we will study about acceleration, kinematic equations, and relative velocity, which is given in sections 3.5, 3.6 and 3.7. Till then, goodbye.